dot product is defined between two vectors. For example, we have vector A dot vector B, and it's defined as the following. The result is given by A's magnitude multiply B's magnitude and multiply cosine theta, and theta is the angle between these two vectors. So here is the pictorial representation. We have vector A and vector B. Let's put their tails together, and the angle between them is theta. So let's understand this result. So we don't have any arrow here anymore in the result. So that means that the result of a dot product between two vectors is a scalar. Now let's look at A times cosine theta. What is that? So let's draw a vertical line from A's head to B vector's direction. And A cosine theta is exactly this length. So that's A's projection to B's direction. So we can say A cosine theta is projection of A on B. Of course, you can also say B cosine theta is the projection of B on A's direction. Okay, so the result will be the same. Now let's talk about how to perform vector dot product using components. Suppose we know A is given by AX times I hat plus AY times J hat, and B is given by BX I hat plus BY J hat. Now A dot B and becomes AX I hat AY J hat dot BX I hat BY J hat. We're going to get four terms: I dot I dot J, J dot I, J dot J. And we'll see that I hat dot I hat equals 1, because according to the definition, right, I hat is a unit vector along the x-axis, so its magnitude must be 1. So that's 1 times 1 times, and the angle theta must be 0 degree, because that's the same angle, right? That's the angle between two same vectors. So that gives us 1. Now how about I hat dot J hat? According to definition, it should be 1 times cosine 90 degree. And cosine 90 degree equals 0, so we get 0. And J hat dot J hat is the same as I hat dot I hat equals 1. Okay, so now we can look back at this expression. So we can only just keep the diagonal term, AX times BX, AY times BY, and all the cross terms disappear. So the result is given by AX times bx plus ay times by.